Welcome students. The progress of human civilization has been dependent on the use of metals. The journey started with the invention of fire, then the tools made of stones, then copper and bronze, and finally the iron. In this unit, we will discuss classification of elements, occurrence of elements, minerals and ores, physical and chemical properties of metals and non-metals, uses of metals and non-metals. There are about 118 elements known at present. It is difficult to study and describe all the properties of all these elements separately. So, all the elements have been divided into a few groups in such a way that the elements in the same group have similar properties. Such grouping of elements is called classification of elements. The elements have been broadly classified into two categories, metals and non-metals, and this classification is based on the differences in their physical and chemical properties. The Earth's crust is the biggest source of metals. The mode of occurrence of metal is dependent on its chemical nature. Most of the metals are relatively inert and hence they occur in free or native state, but most of the metals are reactive and hence they are found in combined state. The compounds of metal found in nature are there in oxides, carbonates, sulfides and chlorides. Highly reactive metals like sodium, potassium, aluminum, zinc are found in combined state. Less reactive metals like gold, silver and platinum are found in their elemental or free state. Copper and silver metals occur in free state as well as in the combined state. Non-metals like oxygen and nitrogen are found in free state. Many non-metals exist in nature in the form of their compounds like oxides and nitrates. Sulfur exists in free state as well as in combined state. Carbon exists in its native state as diamond, graphite and fullerene, whereas carbon exists in nature in the form of its compound like carbon dioxide and carbonates. Elements like silicon, boron, antimony and germanium show the property of metals as well as non-metals, as these elements are called metalloids. The naturally occurring inorganic substances which are obtained by mining are known as minerals, and some minerals may contain a large percentage of metal, whereas other minerals may contain only a small percentage of metals. Some minerals contain objectionable impurities which hamper the extraction of metals, and these minerals cannot be used to extract metals. Those minerals from which the metals can be extracted conveniently and profitably are called ores. Ores contain good percentage of metals and there are no objectionable impurities in it. Thus, all ores are minerals, but all the minerals are not ores. This is the example of hematite. Hematite is the ore of iron and it contains iron oxide. After the mining of the ore from the ground, it must be converted into pure metal, and the branch of science that deals with the extraction of metal from their respective ores and the preparation of alloys is called metallurgy. And metallurgy of each metal is individual problem, and line of treatment depends upon the nature of and the chemical properties of the metals. And some common steps are concentration of ores, reduction of metals and refining of metals. The ores obtained from the earth contain large quantities of foreign substance, and these unwanted impurities like rocky matter, sand, limestone, present in ores are called matrix. So, it is very necessary to remove the ore from the matrix. And the process of removal of these impurities from the ore is technically called concentration or ore dressing. Actually, reduction is the process of treating the metal ore to get the metal in its free state. The method of reduction to be used depends upon the reactivity of the metal to be extracted. Metals obtained by reduction process still contain some objectionable impurities and hence have to be refined. This technique vary from metal to metal and also depend on the use to which a metal has to be put. Most of the metals are solid and lustrous. They have high melting point. They are malleable, ductile. They are good conductor of heat and electricity, and they are sonorous. Let us discuss one by one. Metals are solid at room temperature except mercury, which is a liquid metal. Most of the metals like copper, iron, aluminum, silver and gold are solid at room temperature. And they are lustrous. By saying lustrous means they have shiny surface. And the property of metal of having a shiny surface is called metallic luster. And the shiny appearance of metal makes them useful in making jewelry and decoration pieces. And they have high melting point. Iron metals, for example, iron metals have high melting point of 1535 degrees Celsius. It means that solid iron melts and turns into liquid iron on heating to high temperature of 1535 degrees Celsius. Similarly, copper metal has melting point of 1083 degrees Celsius. But there are however some exceptions like sodium and potassium metals have low melting point. Gallium and cesium metals have low melting point. The melting point of gallium and cesium metals are so low that they start melting in hand or by the heat of our body, and they are malleable. Metals, most of the metals are malleable. Gold and silver metals are some of the best malleable metals. It means it can be drawn into thin sheets without breaking. Silver foil are used for decorating sheets. Similarly, aluminum metal is quite malleable and can be converted into thin sheets called aluminum foil. And aluminum foils are used for packing food items like biscuits, chocolates, medicines. And copper metal is also highly malleable, and copper sheets are used to make utensils and other containers. Similarly, iron sheets are also used to make boxes, buckets, water tanks, etc. And metals are ductile. Metals such as copper, aluminum, magnesium and iron are available in the form of wires. And the property which allows the metals to be drawn into thin wires is called ductility. Gold is the most ductile metal. For example, just 1 gram of gold can be drawn into thin wires about 2 kilometers long. And silver is also among the best ductile metal. Copper and aluminum metals are also very ductile and can be drawn into thin copper wires and aluminum wires, which are used as electric wires. Iron wires are used for making wire gauge. Magnesium wires are used in science experiment in the laboratory. Similarly, thin wires of tungsten metal are used for making the filaments of electric bulbs. Metals are good conductor of heat and electricity. Good conductor of heat means metals allow heat to pass through them easily. Silver metal is the best conductor of heat. It has the highest thermal conductivity. Copper and aluminum metals are also very good conductor of heat. The cooking utensils and water boilers are usually made up of copper or aluminum metals because they are very good conductor of heat. By saying that the metals are good conductor of electricity, it means metals allow electricity to pass or electric current to pass through them easily. The metals offer very little resistance to flow of electric current. Silver metal is the best conductor of electricity. Copper metal is the next best conductor of electricity, followed by gold, aluminum and tungsten. And the electric wires are made up of copper and aluminum metals because they are very good conductor of electricity. Electrical conductivity is another characteristic property of metals. Metals are sonorous, means metals produce sound. If we suspend a big piece of metal and strike it with an object, we will find that it makes a ringing sound, and we say that metal is sonorous. And the property of metal of being sonorous is called sonority or sonorousness, and it is due to the property of sonorousness that metals are used for making bells and strings of musical instrument. Non-metals are solid, liquid and gases. Non-metals have low melting point and boiling point, and they are not malleable and ductile, and they have dull appearance. Non-metals are insulator except graphite. Thank you. In next video, we will discuss chemical properties of metals and non-metals.